Welcome to the Explainer. Today, we're digging into one of the biggest challenges in AI, memory. And we're not just talking theory here. We are dissecting a real, practical architecture for building an AI that can actually remember, learn, and get better over time.
So let's start with a problem that I'm sure you've all run into. You have this incredible chat with an AI. It feels like it totally gets you. And then you start a new session, and it's like you're complete strangers. It's a kind of digital amnesia. And it's the one thing that separates a cool demo from a truly intelligent system.
You see, this forgetfulness creates this massive gap between two kinds of agents. You've got your reactive agent, which is, a brilliant but totally forgetful tool. But the real goal is an accumulative agent, one that builds on every single interaction, that personalizes what it says, and that actually gets smarter.
So here's the crucial point. To get from one to the other, we have to stop thinking about AI memory as just a chat history. It has to be this sophisticated, dynamic system that's built from the ground up for super fast and accurate retrieval. I mean, we literally have to build it a brain.
Okay, so let's dive into this architecture. This model breaks memory down into 4 totally separate layers, and each one has a very specific job to do. And that separation, that's what makes the whole thing so powerful.
So you've got short-term memory for what's happening right now, long-term semantic memory for facts that stick around, episodic memory to store actual experiences, and then a working memory that's basically a temporary notepad. We're going to break down every single one.
First up, short-term memory. Now, this is not just a list of the last few things you said. Think of it as an active token budget management system. You know how an LLM can only pay attention to so much information at once? That's its context window. Well, this layer's job is to manage that limited resource like a hawk.
So its main gig is to keep the conversation making sense and to hold on to what you're trying to do, all while making sure the model doesn't run out of that precious attention space. And it has a really clever trick for this. Instead of just letting old messages drop off, it actively summarizes the key points, keeping the important stuff without all the clutter.
And here's what that looks like in practice. Instead of feeding messy, raw text from way back in the conversation into the model, it boils it down into a clean, structured object like this. It pulls out your preferences, your goals, your constraints. It's brilliant, right? It saves a ton of space and keeps the most important context perfectly clear.
Okay, on to the next layer, long-term semantic memory. This is the AI's permanent library. This is where the agent stashes away all the durable knowledge, the facts, and the key ideas it's learned, so it can use them in the future.
So how does it do this? Well, it's pretty cool. It takes a piece of information and turns it into a mathematical representation, an embedding. Think of it like a numerical fingerprint for an idea. It stores all these fingerprints in a special vector database that's amazing at finding similar concepts. So when the AI needs to remember something, it just searches for the closest mathematical match and pulls that info right into its prompt. Now, getting this right is where the real engineering magic comes in. How do you split up the text? How do you tag it with metadata? And you have to make sure you never mix different versions of your embedding models. These aren't just details, they are the difference between a system that works like a charm and one that just silently fails. This next layer, episodic memory, might just be the most powerful, and yet it's the most underused part of AI agents today. This is where the agent stores its own life experiences, the results of every task it's ever tried to do. I mean, it logs everything, whether a task worked or failed, the exact tools it used, how long it took, how much it cost. By building this super detailed log of its own performance, the agent is creating a data set that it can use to learn from. This is the foundation for genuine self-reflection and improvement.
And check this out. This is what one of those records actually looks like. The agent tried to generate an architecture. It gave its own work a quality score, and it even noted what went wrong, a retrieval mismatch. This is the exact kind of feedback loop that lets an AI genuinely learn from its own mistakes. And finally, we've got the fourth layer, working memory. This is just the agent's temporary scratchpad. For any complex, multi-step job, the AI needs a place to jot down its thoughts, its calculations, its plans before it gets to the final answer. And it is so important that this scratchpad is kept separate from the long-term brain. You just don't want to junk up its permanent knowledge base with messy, temporary notes. This memory is designed to be completely wiped clean the second a task is done, keeping everything else nice and pristine.
Okay, so we've got our awesome 4-layer model. But how do you go from a cool demo to a robust, reliable system that you can actually use in the real world? This is where the theory hits the road.
One of the keys to making this work in production is something that might sound a little weird.
managed forgetting. You have to set aging policies. That means setting expiration dates on some data, giving more weight to newer information, and letting memories the AI isn't sure about just fade away.
And of course, we have to talk about the serious stuff. An AI's memory is a huge liability if you don't handle it right. For any real-world system, you need airtight privacy controls, keeping user data separate, stripping out personal info before it ever gets stored, and making sure you can delete data when you're asked to.
But how do we know if all this hard work is even worth it? Well, you got to measure it by creating what's called a memory contribution score. Basically comparing the AI's performance with and without this brain, we can see the difference it makes. And the results are just dramatic. It's a massive leap in quality.
So, what does this all mean for the future of artificial intelligence? It points to a pretty fundamental shift in where the next big thing is going to come from.
And really, this is the core idea right here. We can keep building bigger and bigger models, but the real jump, the one that gets us to truly smart, autonomous agents, that's going to come from building better brains, from engineering better memory systems.
So let's wrap this all up. The big takeaway today is that AI memory is not just a transcript. It's not a log file. It's a living, breathing cognitive system. To work, it has to be built for speed, it has to be crazy efficient with its token budget, and you have to be able to measure how well it's working. This is the bedrock that real AI will be built on.
And this leaves us with one last big thought. An AI that can't remember is just a tool. But an AI that can remember its successes, learn from its failures, and remember its history with us, well, that's a whole different ballgame, isn't it? How is that going to shape our world? That's the question we're all facing now.